Hi everyone, welcome to the final video in this series on measurements. In this video we're going to look at the final 3D solid in this chapter, which is spheres. Most of you will have a good idea of what a sphere is. Spheres are found in tennis balls, ping pong balls, the Earth, planets, stress balls, any sort of ball really. So you'll be used to using the letter R for the radius when dealing with circles. And a circle is a set of points that have equal distance from the center. The sphere is the 3D version of a circle. So every point from the center to the exterior of the sphere has the same distance. So it's just like a circle, same distance to all points, but in 3 dimensions rather than 2 dimensions. So I'll just write a brief definition here for future reference. Each point on the sphere has the same distance from the center. Okay, so what do we want to do? We want formulas for the total surface area and the volume. Now, for this video, I'm just going to give you the formulas. You can look online, but I think you'll find the explanations online are quite technical for the sphere. So you're going to need to do some mathematics at university level to really see where these formulas come from. But here they are. The total surface area of a sphere with radius r is 4 pi r squared. And the volume is given by 4 over 3 pi r cubed. Right now, we have no idea where the 4 pi and the 4 over 3 times pi come from. But I'll just make a brief comment. For area, I'm expecting r squared. That is length times length. And for volume, I'm expecting r cubed. That is length times length times length. So even though you might not know exactly why these formulas are what they are, you should at least be comfortable with the idea that r squared and r cubed appear in the formulas for area and volume, respectively. But from this point onwards, we'll take these formulas as given and simply apply them. So let's do an example. Here, I've told you that we have a sphere which has a diameter of 20 millimeters. Now, the reason why I haven't given you the radius is to remind you that the radius is half of the diameter. So if the diameter is 20 meters, that means the radius is 10 millimeters. And only now at this point can I use this number in the formulas. I should not use 20 for the radius because this was the diameter rather than the radius. So total surface area is 4 pi r squared, which is 4 pi times 10 squared. 10 squared is 100, so this gives me 400 times pi. Okay, and if I round this, I get 1256.64. to 2 decimal places. And notice that my unit was millimeters, so I need to write millimeters squared. Okay, the volume is given by 4 over 3 times pi r cubed. So I should write 4 over 3 times pi times 10 all cubed. 10 cubed is 1,000. So this is actually 4,000 over 3 pi. And if I do the calculation, I get the following: 4188.79. And my unit is a volume, so I need millimeters cubed. The mathematics here was very simple. Use the formula and substitute r. The only thing that we had to be careful of was to recognize we were dealing with the diameter rather than the radius. So if you are given the diameter, you should convert to radius first by dividing by 2 before beginning your calculation. So that brings us to the end of this series on measurements. I hope you have enjoyed it, and I hope you found these videos helpful. Please remember to reach out over Teams or in class if you want additional help. Thanks.